Hello and welcome to this video. So we are looking at some of the important interview questions that is been asked over the years. Now if there are any questions which comes outside this video, do let us know in the comment section and we'll try to make another video from there. Okay, so we'll get started. So one of the important interview questions, especially for fresher, is what is Hadoop? So it's very important to know, right? So Hadoop is basically an open source framework which is designed for distributed storage and distributed processing. So you have the data stored in different nodes, that is distributed data. Now for that we use something called as HDFS. So the data is stored distributed fashion, and to process this data we need something, right? A paradigm, a program. So that is what we call as MapReduce. So Hadoop is basically a framework for HDFS, which is distributed storage, plus MapReduce. Okay. Now, what is replication factor and why is it important? Okay. So a replication factor basically refers to a number of times a particular data block is replicated and stored across different nodes. Now, if you see here, right, we have three different nodes. For example, node 1, node 2, node 3. Whatever you see this data, this is basically blocks of data, right? So data is stored in blocks in Hadoop. Now if you see this here red color, this is one block. The same block is been stored here and here. So basically data is duplicated, right? That is what we call as replication. You have one copy here, one copy here, and one copy here. So you have three copies. That means your replication factor is 3. This is what replication factor is, right? Now why is it important? Okay, let's say that you have this data, right? You just have data in one node. Okay, let's just assume it. What will happen if this node fails, right? So that is a possibility. If that node fails, then the data is lost. Now in big data or in any scenario, data is the most important thing, right? So we cannot afford to lose data. That is why what we do is we store this data into different nodes. In case one of the nodes fails, you still have the data coming in from other nodes. So that is the reason why this replication happens. All right. Now, a follow-up questions could be what is under replication, what is over replication, right? So what is under replication? So let's say you have three nodes here, and if one of the nodes is down, so you started with the replication of factor 3, but one of the node is down, which means now you have only 2 copies. So you started with 3, but now you have 2. So that means that is what is called as under replication, which means you started at a higher value, but now you are at a value below that. Now in order to make sure that this is balanced, what happens is a new node will emerge. Okay, so let's say you have node 2 and node 3. Node 1 is down now, so the replication factor is 2 instead of 3. So to balance this, a new node will come here, node 4. Then you will have replication factor 1, 2 and 3. So that way the balancing happens. Okay, now what is over replication? So with the same scenario, let's imagine that let's me take paint. Okay, so initially you had 3 nodes, right? Node 1, node 2 and node 3. And then what happened is one of the node is down. So this node was down, so you had just 2 replication. To balance this is called as under replication. To balance this, you had one more node, right? So now this is balanced. Now what happens if this node comes back live, right? So this node is no longer down, so this node is coming back. Now what happens is you have 1, 2, 3, 4 replication. You started with 3, but now you have 4 nodes, right? 4 replication factors. So that is what is called as over replication. Okay, so now we have to balance this, right? So to balance this, what will happen is the name node will free up the resources on the data node that went down, right? So in this case, this was a data node that went down, so all the resources will get freed up here. So the node will be available, but the data, everything will be freed up here. And so that way you will come back to 3 nodes, 1, 2 and 3. So the balancing happens here. All right. What is Apache Zookeeper? Apache Zookeeper is basically a coordination service. So what happens is, let's say in case of Hadoop, Zookeeper is a service which will help you with coordination with your Hadoop node. So Zookeeper will monitor your name node, it will check his heartbeat, it will coordinate with the other node. So that's where this Apache Zookeeper is useful. And not only Hadoop, there are many other services like Kafka where Apache Zookeeper is being used. So Zookeeper is basically for the coordination service. Okay. Now, what is split brain scenario? So this is a question which been asked not too frequently, but it's a very important question. So let's understand what is split brain scenario. Okay, so let's say you have a name node and you have a standby node. So this is the normal thing, right? From Hadoop 2, you will have a name node, you will have a standby node. Now the Zookeeper will basically coordinate with the name node, right? So let's understand this with a diagram. So let's say you have, this is your name node, and you have a standby node, and somewhere here you will have a Zookeeper, right? So this is your Zookeeper, this is your Zookeeper, and this is your name node, and this is your standby node. Okay, and what will happen is the Zookeeper is going to monitor this name node. All right, and now this name node is going to send the heartbeats, basically a signal acknowledgement saying this is healthy. Okay, so now what will happen is since this is a name node, right? So this name node, how will you know this is a name node that has been communicated? So there would be something called as inuse.log. Okay, so inuse.log file will be there in the name node, which is basically to tell you like this is a name node that has been communicating with the Zookeeper. All right, now imagine a scenario that this name node is down. So whatever be the reason, this name node is down. Okay, now what will happen is the Zookeeper will ask the standby node to come and pick up. Okay, in this way this standby node will now become the name node, so you will have only one name node. Now this Zookeeper will then create a file in use.log. Okay, so this way you will have a standby name node acting as a name node. Okay, now what will happen is, let's say if this name node which went down, it came back, right? So in this scenario, what happens is you have a scenario where you have two name nodes. You have name nodes, this is one name node, this is one name node, both of them are using inuse.log. Okay, now this scenario is called as a split brain scenario. Now what will happen is Zookeeper will send a small file Java program to this name node, and it will remove this inuse.log, and then this name node will become as the standby name node. Now that's the concept of split brain scenario. Now what is data serialization and why is it important? Okay, so serialization is a process of converting the data structure of an object into a format that can be easily stored or transmitted over a network. Okay, so let's again understand with a simple example. So let's say you have data here. So whatever be your data, let's say this is my data. Okay, or I'll just simply say data. So this is what I have, this is my data. Okay, now what will happen is this is in your readable format. Now this format can be converted into another format. So let's say this format would be something like this. Okay, so basically very unreadable format. So this is readable format, this is unreadable format. Now why we convert this into this format? Okay, now by the way, this process is called as serialization. You convert the data from here to this format which is unreadable. So this is your serialization. Now why this is important or why is it useful? So serialization, they are easy to transmit over a network. So you can transmit your serialized data over a network. You can send the data over a network easily. So that would be very fast. That is the main reason. And also there are some serialized formats which offer good compression and encryption. So this data can be compressed and encrypted, so it is secure as well. And also when you deserialize, right, so you cannot read this data. So you can, if you do a deserialization, then this data will again come back to this one. So you can basically converting the data from this format to the readable format. That is called as deserialization, and it is also very easy to do. So those are the advantages of serialization. in big data you will actually use a lot of serialized file formats. So another question could be like, what are those serialized file formats? So these are the some of the serialized file format, like sequence file format. You have RC, ORC, Avro and Parquet. So sequence and RC is something which is very old and is something which is not being used very frequently. I don't think anybody is using now. Maybe very, very old legacy systems are still there, but any new projects or current projects are using either ORC, Avro or Parquet. Okay. Now, what is the difference between the file formats, this Avro, ORC and Parquet? So Avro is a row format and ORC and Parquet columnar format. All right. Avro is row format, ORC and Parquet are columnar format. Because the Avro is row format, it is write heavy, while ORC are read heavy. And in all these file formats, along with the data, schema will also be there. Okay, that is one common thing that's not really different. Now all these file formats can be split across multiple disks, therefore scalability, parallel processing is not an issue. And if you talk about compression, ORC provides maximum compression, then followed by Parquet, then followed by Avro, because Avro is row format, right? So it will provide the least of compression. It does provide some compression, but very, very less compared to the other two formats. Now, if the schema keeps changing, let's say today you have 3 columns, tomorrow you may have 4 columns, then tomorrow they may come back to 2 columns. If the schema keeps on changing, then we would use Avro, because Avro supports schema evolution. ORC also supports schema evolution, but to a very, very less extent. But typically what we do, if there is a schema changes that is happening, then we go with Avro. So Avro is commonly used in streaming applications, Parquet is commonly used in Spark, and ORC in Hive. So Parquet is very good in storing the nested data. So usually Parquet is used, and also Parquet is the default file format in Spark. Now, as I mentioned, like ORC provides maximum compression, right? So because compression of ORC is more, it is used for space efficiency. If you want to save more space, you can go with ORC. Query time will be little more, because you have to decompress the data for us to read, right? So you can encrypt or you can compress the data, but in order for us to read, you have to decompress, so that time will take more. In case of Avro, the time efficiency would be good, as it takes less time to decompress, right? Because it has a less compression. So if you want to save space, you have to use ORC, but if you want to save time, because the processing is good, you can use Parquet. So these are some of the differences between the Avro, ORC and Parquet. Most important is the compression. ORC provides the maximum compression, and then ORC used in Hive, Parquet used in Spark, and Avro is commonly used when there is a schema changes. Okay, this is something that you have to remember. This is sufficient. Now, what is columnar storage? So we talked about ORC and Parquet being columnar storage. So what exactly is columnar storage? So traditionally, if you use any RDBMS like MySQL or Oracle, so the data is stored in rows. So this is called as row storage. So for example, if you see this data, right, this is one row, maybe ID, name, state and age, and then another row. This is how the data gets stored in the blocks. Now, what is the advantage of this is that if you want to get the data of a complete, let's say complete row, let's say you want to get data of Elizabeth, so it is stored in one block, so you can retrieve it. So what is the disadvantage here is that let's say if I just want names, right, I want John, Elizabeth, Scott, so because they are stored row by row, so only after this entire row the other data will be stored. So that way, even though I want one column, it may be stored in different data nodes or data blocks. So that is one disadvantage. Now, what is column storage? See, instead of storing by row, what it does is column stores by column. So let's say all the ID data, so all the ID data will be stored first, then all the name data will store, and second the third column data will be stored, right? So that way all the data belonging to one column will be stored most likely in the same node or same block. So that way when you do a select of one column, you can actually get all the data from one node or one data block. So you will minimize the number of scans, right? That's the advantage. So if you want to query the values of certain columns, let's say IDs, then you can query from one block or one data, whatever blocks that they are spread. And that also helps you with aggregation, because aggregation you don't select, let's say you have 100 columns, you don't need 100 columns for aggregation, right? Like 2 or 3 columns. Now disadvantages, again we talk about advantage, we should also talk about disadvantage. So let's say you want to add any new record, right? So let's say a new ID, new name, state and age came. So then what you have to do is you have to add it here, ID. Basically you have to make a space, then you have to add name here, again you have to make a space. So that becomes a little difficult here. So the next question is, what is Hadoop small file issue? So this can be asked in different way as well. So one question would be, what is small file issue? The same question can be asked differently, like, okay, kind of a scenario. Let's say I have many small files and I want to do it, I want to load them into Hadoop. Is this a good idea? Okay. So first understand what is small file issue. Okay. Small file is basically, issue is basically trying to process many files, right? So this person wants to process many small files. So Hadoop is more suitable for large amounts of data, right? You can take one large file and load it in, that would be a lot better than taking a lot of small files. Now why is that? Because the name node will store the metadata information of the file in the RAM. So you have 100 files, each file metadata will be stored in the RAM. So what will happen with more number of small files is more metadata is stored in the RAM, and then there is a lot of load on the RAM. So this is not good, right? Your RAM should not be overloaded. So that is why it is always advisable that you do not load small files, because that will put a lot of strain, lot of load on your RAM, because the metadata has to be stored there. So that is what your small file issue is. What happens when two clients try to access the same file in HDFS? Okay, let's say there is a file, this and two clients, maybe two queries. Let's say this is a file, and we have two clients here. So basically you are sending some queries or application, whatever it is, they're trying to access this file. So what will happen? Okay, now they can access this file for read operation or for write operation, right? So read is just reading the data. So if it is a read, then it's not a problem, it can have concurrent access. So this file can read at the same time, this file can also read at the same time. But if they are using for write, then what happens is whatever the file that requested first, that will be locked. So this client may request this file first, so this is then locked by this client. Now this client, the second client, now if it try to access this in a write mode, it will not give that, because some changes have been already made by this client, so it has to wait. Now why this is important? Because if you're making, two people are trying to make the changes, then there will be inconsistent, right? So that's why one client or one person will be allowed to make changes in one time, and then once that person is completed the changes, then it will be released and the other person can make their changes. Okay, what happens when the name node is down? So simple thing, right? When the name node is down, standby name node will take its place. We have already seen this, and then the standby name node will become the name node. Okay, and if the name node comes back, then a split brain scenario happens. We have seen that. And then what will happen is the original name node will become the standby name. Now during the time, whatever little time when the name node is down, we cannot communicate with it, and so all your queries to the name node will fail. Okay, what is JPS command? So JPS command is a Java process status. So basically when you run this JPS command, what happens is it will give the list of Java processes that runs. Okay, you can see here in the screenshot, when I put a JPS, these are the services, Java services that are running, like an NiFi is running, right? So this is important in a DevOps when you want to see what are the process that is running, and if you want to kill it from the backend, this command will be very, very useful. What is shuffling and MapReduce? So shuffling is a process of redistributing and exchanging data between different nodes in a cluster as part of data processing pipeline. So it happens when you apply actions, let's say aggregation. So let's understand this a little bit more. So let's say So you have data in different nodes. Let's say data is here, data is here. Let's just take two examples. Okay, so you have okay, this is one node, this is one node. All right, now what you're doing is you have some data here and you are trying to get the count of the data. Okay, let's say what data we have is we have fruits data. So okay, so you have like two apples, then you have mango, which is three. Okay, similarly what will happen is here you have apple of 4 and then mango is 2. Okay, now what will happen is because the data is present here, data is present here, right? Now if you want to count the number of apples, you have to bring the data to a common place, right? You cannot count here and you cannot add it here. So what happens is you bring the apple data, all the apple data to one place, similarly all the mango to n place. So this process is called as shuffling. You redistribute the data. So shuffling basically happens during the aggregations or action. Now this will reduce your performance, but wherever it is required, it has to happen. So that is what shuffling is. So what are the steps involved to submit a Hadoop job? Right, so Hadoop job, what happens is you submit the job or the executable file jar to the resource manager. Now the resource manager will then distribute the configuration to the slave, which is your data nodes, and then it will schedule the task, it will monitor it, and then finally the job status, everything information will be provided back to the client. So that's what happens. Okay, what is speculative execution in Hadoop? So what happens in Hadoop is if nodes do not fix or diagnose a slow running task. So let's say there are some slow running tasks and the data nodes are unable to fix it. What will happen is the master node will perform another instance of the same task or on another node. Okay, so the same task will be performed on another instance of this node. This is called as a speculative task, and this process is called as speculative execution. Right, so the next is which file format is better, Parquet or so we have already seen this, right? Parquet and ORC have its own use case, right? ORC provides better compression, Parquet is good in stored in nested data. So processing would be better in Parquet. So if you are using Parquet, that means you want to do better processing of the data. If you want to save space, you can use ORC. All right, again ORC is used in Hive commonly, Parquet in Spark. So this is a very interesting question. Okay, so this we have seen in one of the interviews. Let's say I have a file which is 100 GB. Now I have compressed this file using two techniques. So it's the same 100 GB is compressed as 10 GB using one technique and then 70 GB using another technique. Now I have to write queries on this compressed file and see the result and verify which file should I use to get the faster response. Okay, so very interesting. So let's say this is your 100 GB, right? So this is your 100 GB data and now this has been compressed into this is your 70 GB and the same data, it's just a compressed one, and another is it's a 10 GB. Okay, now what will happen, what he's asking or what the interviewer is asking is, so let's say if I have to write queries, so I can write queries on this data and I can write queries on this data, which will give me faster result. Now if you look at this is a smaller data, so and this is a bigger data, right? So usually some people might get confused and say this will give the better faster result, but this is compressed data, so you have to decompress it. So if you have to decompress 10 GB to 100 GB, it will take a lot more time than uncompressing 70 GB to 100 GB, right? So that is the reason why this answer is wrong. 70 GB will give you faster result because it will take less time to compress the data. So that's the answer for that. What happens when a user submits a Hadoop job when the name node is down? Okay, so we have already seen this, the job will fail when the name node is down. What is rack awareness? All the data nodes put together form a storage area. So you have different data nodes, so that basically you call it a storage area. That is the physical location of the data nodes. So this is referred to as a rack in HDFS. All the data is put together. It's a rack. Now the rack information, that is like which rack ID of each data node is acquired by the name node. So name node maintains all this metadata, right? So the process of selecting the closer data nodes depends on the rack information. So this is called as rack awareness. So the name node should know like where that rack is and which rack ID is closer to the node. So that information and everything will be maintained by the name node, and this process is known as the rack awareness. How will you choose various file formats for storing processing using Apache Hadoop? Again, this is also something that we have already seen. So if your schema is changing, yes, use Avro. If your usage pattern is to select few columns, let's say 50 columns here, but you want to query only 5 columns, then you use the columnar format, right? Parquet may be a good fit. We have already seen this also. Now, if you need data to be processed in parallel across distributed cluster, formats like sequence, Parquet are advantageous. Sequence is something which we don't use regularly, so I would go and say Parquet. And for a balance between read, write and transfer performance and optimization, again Parquet is a very strong contender. Again, it supports a block level compression, provides performance benefit. It also has a very good compression technique, so that way it will also save some storage. So typically Parquet is the most preferred one in big data, especially in Spark. Now, why aggregation cannot be performed at mapper side, right? So we cannot perform aggregation mapper side because it requires sorting of data. So if you want to provide any aggregation, you have to sort the data. So this sorting occurs only at the reducer side. That's why we cannot perform aggregation on the mapper side. So for aggregation, we need the output of all the mapper functions, which is not possible during the map phase, as map tasks will be running at different nodes where the data blocks are present, right? So that's the answer for that. How do reducers communicate with each other in Hadoop? It's a very tricky question, right? How do reducers communicate with each other? The answer is reducers do not communicate, right, with each other. Reducers always run in isolation, and MapReduce programming never allows them to communicate with each other. All right, so very tricky question. What are the phases of MapReduce? So you have three phases: shuffle, sort, reduce. We have already seen what is shuffle, right? The sorted output of one mapper is an input to the reducer, right? So you basically shuffle the data from one node to another. Sort phase, what happens in this phase is the input from various mappers, they are sorted based on some keys. This framework groups the reducers inputs by keys. Shuffle and sort, they happen simultaneously currently. Okay, reduce phase, as you know, in this phase reduce task aggregates the key value pairs after shuffling and sorting phase, right? So for example, a collect method, this method writes the output to the reduce task of the file system. These are the three phases of the MapReduce. What is the difference between structured data and unstructured data? So now data can be stored in traditional databases in like rows and columns. So this is your row and column. So you have ID, you have name. So this is a structured way, which means you have ID which is in numbers, you have name which is in alphabets. So data, and you have two columns. So this is a structured way. Now there may be other formats like XML, right? So these are called semi-structured data. Now why that is semi-structured? You have a schema XML, but then within that you can have many elements, right? Now what is unstructured? Unstructured is unorganized data. So those are called the unstructured, like your tweets, they don't have any structure. Your reviews, anybody can write anything, right? Your blogs, your audio, your video, they all are examples of unstructured data. What are the different modes in which Hadoop runs? So we have three modes. One is your local mode, which is also called a standby load. This is the default mode where the Hadoop is configured. In this mode, all the components of Hadoop run on a single Java process. Okay. Pseudo distributed node is again a single node cluster, but Hadoop runs on a single node in a pseudo distributed mode. Each Hadoop daemons work in separate Java process in a pseudo distributed mode, while in local mode they all operate as single. That's the difference between standalone and pseudo distributed. So in standalone it runs as a single Java process, but in pseudo distributed mode it runs in all the process runs separately. Okay, fully distributed mode or multiple cluster modes, in this all the daemons are executed in separate nodes, building into multi-node cluster in the fully distributed mode, right? So these are basically the questions that we have gathered. I hope this is useful for you. If it is useful, please do leave us a comment and consider subscribing to our channel. Thank you so much.